Morning, Ryan. Morning, Logan. Morning, Jack. All right, so the agenda was posted in Classroom earlier. Pretty straightforward. Not sure how long the stream is going to be, but maybe shorter than normal because a lot of it is just kind of getting ready for the test and it's working on the study guide. So I will review modeling eclipses, the extend and the evaluate sections, especially those of you that are interested in revising. The extend section was a little bit of research onto that timeanddate.com website for eclipses in Coventry and across the planet. The eclipses for Coventry kind of were a little confusing a little bit depending on where you looked in the chart. Kind of show you where I wanted you to look if you lost some points in the extend section. And then evaluate, just quickly go through what my expectations for the answers were. I think a lot of people miss just one small point that I want you to have for both answers. All right. We'll review part 1 of the study guide. That's 1 to 4. And then I'll guide you a little bit on part 2 and 3. We'll do number 7 together. All right, and that'll be the wrap for today. Hi, Kaylee. So if you have any immediate questions, let me know. If you have study guide questions, just hang on a little bit. If you have modeling eclipses questions, I'm going to go over that right now. Hi, Hayden. And I saw your response, Hayden. I'll get to it in a little bit. All right, so doing the extend section. Just a quick review of it. All right, eclipses are based on the positions of the sun, the earth, and the moon. Since revolutions are cyclical, they are predictable. Use this resource to help you conduct some research on eclipses across the earth and Coventry itself. So 14 and 16 were the two that you were looking for, just in general, the next eclipses. Open up the source, close out of that. And I'm just looking for the next 2 eclipses. And so I don't know where some of the dates are getting pulled from. Most of you did well on this 2 questions, 14 and 16. The next, just simple next solar eclipse is June 21st. Technically, it's not a complete total eclipse, but I mean, we're going to call that, for our sake, a total eclipse. June 21st, total eclipse for most of Southeastern Asia, Central Asia, the Middle East, and Central Africa. And then I put that in there. When's the next solar eclipse? June 21st, and the locations. It'll be a total. For our sake, we'll call it total. 16, when's the next lunar eclipse? Well, June 5th. June 5th into the 6th. It'll happen over midnight in those locations. Of, again, most of Asia, adding in Australia, the Middle East, Africa, and Europe. More, or a greater location, because the moon takes up a bigger, or the Earth has a bigger shadow, and the moon is small, and it takes longer to move through the Earth's shadow than it takes for the Earth to move through the moon's shadow. Right? So that's kind of going up into the top portion on why lunar eclipses are longer and why lunar eclipses are more common, because the Earth's bigger. So it takes a longer time for the moon to move through the Earth's shadow, move through the Earth's, say, the direct shadow, the umbra. All right. In this case, it's going to move through the Earth's penumbra, or the indirect shadow. So it'll be a penumbral eclipse, right? So now the follow-ups, 15 and 17. Why won't the entire planet be able to see the next solar eclipse? Because the moon is so small, it's only going to cast a very small, a relatively small shadow across the planet that very few people in very few locations will see that umbra of the moon fall on the Earth. All right, we watched a video yesterday of them being in the umbra of the moon. Not everywhere was in complete darkness. They even on the edge of the umbra, they saw like a sunset or like a morning, a sunrise across the entire, in all directions. So not everywhere was in darkness. Follow up again for the lunar eclipse. Why won't the entire planet be able to see the next lunar eclipse? Because half the planet literally is turned towards the sun during the lunar eclipse. And so this question just kind of reinforces that the Earth is a sphere, that the half that faces the sun is in daytime, and the half that doesn't face the sun is in nighttime. And you can only see the moon, a full moon, during the nighttime. So you'll see the full moon eventually, but you won't see the eclipse because full moon is a very precise alignment. All right. For the lunar eclipse, we have the sun, the earth, and then the moon behind it. All right. Hi, Rainy. Morning. So those were the first four, and I kind of broke that section down into two parts. And we came back this week and we did 18 through 21, and they were all about Coventry. So when's the next penumbral lunar eclipse that will be visible in Coventry? So this one was tough if you didn't know where to look. Tried to guide you, but I wanted you to do it on your own because there's not a lot to figure out. Here's a list of the next eclipses until 2022. You can change the decades to find the next, or you can just hit all eclipses from 1900 to 2199. All right, but most of your answers here in this chart, and I would say use this picture because technically speaking, maybe 1% is not a total eclipse. For our sake, being mostly red, we'll call that a total lunar eclipse, just so you guys get familiar with what it would look like. All right, so when is the next penumbral lunar eclipse? Right, start top of the list, July 4th, 4th of July, next penumbral lunar eclipse. So I go back to my document, I mark that down, I write that down, right? 19 was the next total lunar eclipse. Technically, this is mostly red. This is as close we're going to get in the immediate future to a total lunar eclipse. I'd mark this down. I'd say Thanksgiving of next year, almost Thanksgiving of next year, November 19th, 2021. I'd put that down. Okay? The next one, when is the next partial solar eclipse? It's right here, partial solar eclipse. I think some people were looking over here on, now it's highlighting the whole thing. You're looking over here, visibility worldwide. I'm not interested in visibility worldwide. Okay? Just like that eclipse that we saw earlier, it looks like a total solar eclipse if you're in that tiny, tiny, tiny red line within the orange pathway of the moon's umbra. Well, I want you to look here, visibility from Coventry. You're at a different angle because you're at a different place of the Earth regards to most of the Earth. So this is the maximum the eclipse will be at. This is what you see from Coventry. All right. So you're supposed to be looking from the left side, not the right side. I think some people were looking on the right side, but that's visibility worldwide. I wanted you looking from visibility from Coventry. Okay. So the next partial solar eclipse is June 10th, 2021. So next summer. All right. And this is the one that very few people got. I know in chat there's a lot of you trying to find it, getting frustrated. Eric was saying it was impossible, didn't exist. No, just because it's a low chance doesn't mean it's impossible. Just means it's very rare. Eventually, we had Ryan find it finally, right? We're looking for the next total solar eclipse. Well, that's none of these for Coventry. So let's go to, let's see, that's 2021. Let's go to the 20s. Partial lunar, total lunar, total lunar. Partial solar, partial solar, partial solar. No, nothing in the 20s. All right. 30s. Nothing. All right. 40s. Nothing. So at this, Mercury transit. You know, this is what I think John or somebody say that they thought that this was an eclipse. This again, not an eclipse, but the next Mercury transit that we can see. 2049. Even though you won't really see it. To the 50s. Partial solar. Nothing. At this point, you guys are getting frustrated because you're like, I must have missed it somewhere. It can't be much further. Like it couldn't be in the 70s. It couldn't be 50 years from now. Oops, I went too far. That's what my problem was. It couldn't be 50 years from now, could it? May 1st, 2079 is a total solar eclipse for all of the planet. It is a total solar eclipse for Coventry, Rhode Island. So that question right there, you want to fix it, you can add that in. May 1st, 2079. Okay? Can you make it 59 more years? This is indirect shadow of the moon, and then the umbra. So the umbra just starts right there at Rhode Island. So in 2079, even though it's so rare, we almost miss it. Because that's Cape Cod, right at the tip of the cursor. It's like right off the coast of Block Island when the umbra finally reaches and is in line with the Earth. So even Coventry almost misses it at this eclipse. It took 59 years to get to that moment, and it's almost missed. So pretty interesting. No, Rainy. So that was the extend. The evaluate now, that's what I did the diagram for. What conditions and variables are needed for 22 and 23. You would need that perfect alignment that I diagrammed. You would need the sun, the moon, and the earth in that order, with the moon in between for a solar eclipse. To have the umbra fall on the moon, fall on the earth. And in order to have this perfect alignment, you have to really emphasize for me, though, that the tilt of the moon's orbit is at 0 degrees, and the moon is in a new moon phase. The moon is in a new moon phase. It's the only time you'll see the new moon. So I emphasized that yesterday. What conditions and variables in the soon Sun, Earth, Moon system allow for a lunar eclipse. Drew it yesterday. Sun, Earth, then the Moon. Moon's behind the Earth. The Moon moves into the Earth's umbra, direct shadow. To have that lunar eclipse, you would need to have the Moon at a full moon phase. So I wanted you to really emphasize the phase of the Moon because that tells you location of the Moon. And the Sun and the Earth relatively are going to stay in the same kind of perspective for the Moon, but the Moon's the one that's moving the most between those three objects in relationship to those three objects, and that's the one that's going to really determine the effects and the phenomena that we've been looking at. Lunar phases, position of the Moon. Tides, position of the Moon. But in relationship to how fast the Earth rotates. Spring tides and neap tides, position of the Moon with the Sun. And then now with eclipses, Sun, Earth, Moon, but again, is the Moon in a new moon or is the new moon in a full moon? That's the only way you're going to get an eclipse. You cannot get an eclipse at the quarters. You can't get an eclipse at the waxing crescent. You can't get an eclipse at the waxing gibbous. You can't get it at a waning crescent or a waning gibbous. It's got to be in that alignment, closest to the Sun and then opposite the Sun. New moon and full moon. Okay? And so you can start to see some of these match together. Spring tide, they match with eclipses. If you can see a lunar eclipse, you have a high tide right now. So those relationships are going to be kind of what's going to be important as you do this study guide. Any final questions on modeling eclipses? Just in case you were stuck, got a little confused. Yes, you can revise it. Just resubmit once you've changed it. No, you cannot submit for a 25 rainy if you're 1 point off. Okay. So looking back at the agenda, we've done 1. We're going to do number 2. And then we'll work on 3. You could also be working on 3 right now too, if you don't need any of those help. Study guide 1 through 4. What is rotation? What is revolution? I would use your key term guide if you're completely stuck. Key term guide, we did come up with a definition for those 2 terms prior to us leaving school and working from home. Number 1, rotation, spinning of an object on an axis. Axis is an imaginary line that connects 2 poles. So the Earth rotates once on its axis every 24 hours. The Moon will rotate once every 27 to 29. We just say on average 28 days, 28 Earth days. So rotation rate of the Earth is 1 day. Rotation rate of the Moon is 28 days. So the Moon takes 28 times longer to do a day. All right. I'll talk about that at the end, Ryan. No, don't mess him up, Jacob. Second question, what is revolution? Revolution, the amount of time that an object takes to move around another object. In astronomy, we usually call it an orbit. So how long it takes for an object to orbit something. All right. What is the revolution rate of the Earth? Earth takes 365.25 days. That's why we have a leap year every 4 years. We add in that quarter day, otherwise our calendar would get off sync. You'd start celebrating different days at different times of the year. Seasons would get out of whack with the calendar. It's not what you want. So you had to add in that extra day every 4 years. The moon takes, again, 28 days. So the moon's the same. Rotation, revolution's the same, 28 days. The Earth takes 365.25 days to revolve around the sun. so much longer, has a much larger orbit. The moon is a moon. Moons are natural satellites. They will orbit a planet, so they have a shorter orbit anyway. All right, planets orbit the sun. Number 3, I went over it a little bit with you. I had some good diagrams sent to me. People were asking, is this good? Does this work for what you were asking for? I said, yep, pretty good. I just wanted you to make sure that you were using like common materials like you would use around your house or in the classroom to make your model. So you can know everything about rotation, revolution, you know the scale, you know the movement, the timing, perfect. Just think about common materials because, oops, am I good? I had a connection issue. Yeah, it looks good. And so somebody also asked, could I just take my model from Modeling Sim System and put the link in there? Yeah, you can do that. Just give me a little bit of explanation again. All right. Thank you. Myopic John. Who's Myopic John? That's a new one. John Delone. Nice. 4. Why does day and night exist? Day and night exists because of, number 1, rotation of the Earth. Half the Earth faces the sun, half the Earth does not face the sun. The Earth is a sphere, or if you want to be technical, an oblate spheroid, right? Well, the half that faces the sun is in daytime. It's receiving solar radiation. The half that is its own shadow is night. The moon also has a day and night. We just get a little more specific and we call those lunar phases. And those lunar phases help progress day and night on the moon, waxing, seeing more of the daytime side, waning, seeing more of the nighttime side, always from right to left across the moon because the moon moves counterclockwise in its revolution. And so lunar phases correlate to day and night on the moon and help us track the moon in its day cycle, which is the lunar cycle, which is its revolution. So this was a review and intro of when we started talking about the sun, earth, and moon, and then where we're going. So you guys are working in part 2 and part 3 today. And then tomorrow, trying to focus on getting as much of the study guide as you can get done. Hopefully finish the study guide or get close to it. Maybe do a couple questions Sunday over the weekend. But we are working on 5, 6, 7, 8, and 9 today. 5, 6, 7, 8, 9. 5, what causes seasons on the Earth? How does it cause them? I would go back to Earth-Sun geometry if you're unsure. Or you could... Modeling Sim System was just the very beginning. I'd go back to Earth-Sun geometry to get a better idea of seasons if you're still unsure about how the Earth has them. 6, draw a diagram. Again, do it on paper, do it in Google Draw. Of the Earth revolving around the Sun at 4 different points according to each season for the northern and southern hemispheres. Also include the point according to the northern hemisphere only for summer solstice, autumnal equinox, winter solstice, and vernal equinox. So you would recognize this as the season diagram. Mr. G, it's in my notebook. Yes, it is. However, we had a weekly quiz, didn't we? So this is diagram of tides. These are special tides. Go a little further back and past. DNA 21. This is lunar phases still. Lunar phases. Diagram of the seasons. And here's our diagram of the seasons. Try doing it from memory, or go back into Classroom, into the stream, and scroll a little bit back into the past to find our notes. Again, the sun's at the center, Earth goes around counterclockwise. This picture can't change. This always stays the same. What can change is the tilt. So if I flip the tilt, I flip when the seasons are. Just like if you go back to Earth Sun geometry, one of the questions is what happens when you flip the tilt? You flip the seasons. All right. Oops. So 5, I'd go back to Earth Sun geometry. What causes seasons on Earth? It's going to be solar radiation, but different angles of solar radiation. Why do we have different angles? It's all due to the Earth's blank. 6, draw that diagram. 7, kind of what we're going to work on in a little bit. Describe daylight, angle, and length during the summer solstice. Describe daylight, angle, and length during the winter solstice. How do they compare? The autumnal and vernal equinoxes. So this is getting into a more in-depth reason for number 5, why we have summer versus winter, and how they compare to the 2 transition seasons, autumn and spring. All right. Downey has a question on number 6. Include the point according to the northern hemisphere only. So I want you to include the Earth at 4 different points around the sun. At each of those points, for the northern hemisphere, tell me, is it the summer solstice, autumnal equinox, winter solstice, vernal equinox? Does that make sense? So these are 4 points around the sun, like 4 points of a compass. At each point, tell me its name, according to the northern hemisphere. Like this is a solstice, this is a solstice, but this is the summer solstice, this is the winter solstice. Okay, good. So we'll do 7 together in a second. So 5, 6, 7, and then finishing part 3. Draw a lunar phase diagram that shows the moon's position around the Earth according to the sun. Include length of time between the major phases. Each quarter. A quarter of 28 is 7. So that's kind of an easy way to remember that, right? Draw the 8 phases. They appear from the Earth in chronological order. So what you are doing here is you are essentially taking your big lunar phase diagram and you're cutting it into 2. You have your moons around the Earth in number 8, and then along the bottom, the key, what you would see from the Earth, is what you're going to put in 9. So you have a lot of drawing to do. 6, 8, and 9. A little bit in 7, but I'm going to try and describe it as best I can. So 8 and 9, taking your lunar diagram. Where is that? So this is a diagram of the seasons, lunar phases. That was Tuesday, March 10th. This is number 8, telling me the moon all the way around. This is 9, identifying the 8 phases in order. All right. So go back to March 10th. All right. This one, find a date for that. Well, the posting was on March 5th, so go back to March 5th. Eric, I don't get 5. You don't get what causes seasons on Earth? If I just ask you point blank, what causes seasons? What's your first response? There's one thing about the Earth that's special that helps us determine the seasons. What is that thing? Different angles of the sun, but there's different angles of the sun because the Earth has a what? Earth revolving around the sun. You guys are right there, but it's because the Earth is also at a what? There you go. There you go. There's a tilt in its axis. There's an angle in its axis, 23.5 degree tilt. And that tilt, when the Earth rotates and revolves around the sun, is going to cause changes in day and night, and it's going to cause changes in the angle of the light. And so I just wanted to use rotation and revolution with a tilt in the axis for 5. You don't have to get into which angle of light's stronger. I'm going to do that in number 7 right now. Okay? I don't really need those arrows. All right, so we're going to do number 7. A little messy, but I'll clean it up where I can. Describe daylight angle and length for summer versus winter. How does spring and autumn compare? In order to have summer, you're going to need, there we go. In order to have summer, you're going to need the Earth with its axis tilted towards the sun. So this is the axis. This is your equator. All right. Northern hemisphere is north of the equator. This would be summertime. This would also be at its greatest extent, the Earth tilted towards the sun. This would be the summer solstice. This happens on around June 21st. Not always the 21st, on average, the 21st of the month. For the northern hemisphere. If you're in the southern hemisphere, this would be the winter solstice, but in the previous question I asked you just include the northern hemisphere. We have a northern hemisphere bias. All right. So now how does the angle and the length compare? No, Eric, I want you to remake it. If you remember back a little bit, when we were in school, we marked these middle ones as direct light, and the light going towards the poles was indirect. So the most direct light is going to land in the northern hemisphere if you follow the arrow, and then some indirect light going to the North Pole. So most of the light is landing in the northern hemisphere, and most of the light that's direct is landing on the equator and north of the equator. So in summer, not only do we have more daylight, more length of time of day, but we also have a more direct angle. That's summertime, right? What's winter like? It's just flipped. Because if you flip the axis, you flip the season. So the Earth goes another 6 months counterclockwise in its orbit. This is a side view, remember? Draw the Earth. Axis is tilted away. Equator's here. Northern hemisphere, southern hemisphere. Draw in the light rays from the sun again. Five rays. 3 are in the southern hemisphere. 2 are in the northern hemisphere. The direct lights on the equator are in the southern hemisphere. Indirect light is mostly in the northern hemisphere. So it's flipped. I said we go 6 months, so this happens when we're tilted away from the sun. This is now the winter solstice. The length of the daytime and the angle depends on your latitude. The more north you are, closer to the pole, the longer your day is going to be. And you're going to get more direct light, but still most of the direct light is near the equator. So there's extremes the more you get away from the equator. What I'm going to just use in terms of length of time, and not so much the angle, but length of day, is it greater than 12 hours of daytime? Is this season less than 12 hours of daytime? Or is it around equal to 12 hours of daytime? And that's what we did in class, right? So summertime now. Summer versus winter. Summer's angle. The light is direct, and daytime lasts more than or greater than 12 hours. That makes more thermal energy. That makes for a warmer temperature over several days. This climate is going to shift to a warmer version of itself. So the weather becomes warmer. Weather over several days and weeks and months becomes climate. So summer is a periodic shift in the climate due to more direct light and longer days. Okay? Opposite's true for winter. The light is mostly indirect. And daytime lasts less than 12 hours. Okay? Well, that's great, but how does spring and autumn compare? You'd have to picture this diagram over to the left, with the Earth either to the north of the sun or to the south of the sun. So kind of just draw a small diagram. Sun, Earth tilted here. Well, it's not tilted to or away from the sun, so it doesn't matter. It's like there's no axis. When the axis isn't involved, it's transitioning from summer to winter or winter to summer, you're going to have mix of direct and indirect light. The day is equal 12 hours of daytime and 12 hours of nighttime. This is called a what? Well, if it's equal, this is the vernal and autumnal equinox. And so the climate becomes what your climate will be based on in terms of your latitude, the radiation from the latitude that you're at, in terms of angle and duration. And so if you kind of think about it, spring and autumn have a very similar feel to them, right? That feel is due to equal angles of light and equal day versus night, daytime and nighttime. You will have warmer days and colder days, colder in autumn, warmer in spring, because you are transitioning from one extreme season to the other extreme season, winter and summer being those extreme seasons, right? So if you're in springtime, like right now, you went through the vernal equinox on March 19th, we're now in April, you should be getting more reliable, more common, warmer days until the average now becomes in the 50s, and then it becomes in the 60s, and then 70s, and then in August, past the summer solstice, it's August, it's humid, it's like 90 degrees. Why? Again, that's because due to water being slow to cool down, the actual temperature and the actual climate does lag behind the sunlight, right? Because most of the Earth is covered in ocean. Ocean absorbs a lot of energy, but also releases it slowly. Remember that thermal battery? We talked about the climates last trimester. So the seasons technically astronomically happen on a regular schedule, but the climate lags. And we also know the climate's changing, and so that also impacts when you have certain seasons happening, right? Summer is happening sooner than normal. Winter lasting a little shorter. This was one of our warmest winters on record. I remember seeing some information from AccuWeather that places like New York and Boston received a quarter or 20% of the amount of snow they normally receive this year. So we are in a snow drought. Interesting. So that's number 7 on the study guide. There were 4 others. 3 of them required diagrams. Oh, I don't want you just taking snapshots of them, Eric. I want you redrawing them because the act of redrawing them will help ingrain it in your memory so that you're able to maybe draw them for yourself at some point to help you understand what you're looking at, or to use in a justification. So this study guide itself this is obviously not going to be a grade like the previous study guides. I didn't grade you on your study guide, but this is preparation. The test is multiple choice with justification, right? So you may be really good and can recall a lot of information, but do you understand it? And so a lot of these answers are going to help you with the justification piece on the test. So this is in your best interest to do it. Again, it's not a grade, but am I trying to help you prepare you for the test? Yeah. Obviously, why'd I waste my time making the study guide, right? Is it going to be on a form? Yes, it'll be one of those locked Google forms. There'll be 15 pages, a page or a section per question. There'll be 2 questions for each part. You'll have the multiple choice, a diagram with it, and then you'll have a box to type in your justification. You'll hit submit. I'll look through your responses. Can you draw the diagram? I can, John. Is there a specific one you want me to draw? But also, I've kind of told you, you can go back to March 5th in the stream of Google Classroom, or you can go back to, and you can go back to March 10th in Google Classroom. This is the seasons diagram. This is the lunar diagram, but just broken into 2 pieces. The test, I believe, as of right now, I don't think I've changed it. I may change it in the future, is 15 questions. Multiple choice part and the justification part. A lot of the multiple choice questions have a picture. It could be a picture of different items. It could be a diagram. You have to kind of answer according to that picture or diagram. Not every one of them, but a lot of them do. Okay, you want me to add in the equinox. All right. Because I'm confused on the tilt. There we go. So I'm just going to draw the sun the same way I was drawn before. So if the sun's... I'm not going to have enough room. Sun's here. All right, so the S is just referencing the summer picture from before, and the W is referencing the winter picture before. Just I flipped them. That's all. I'm just showing you the overall big picture. If I was to draw the autumnal equinox, that's what I would draw inside the black box. Okay? Notice that you can't really tell if the direct or indirect is going towards the northern hemisphere or the southern hemisphere. It just kind of goes straight and it just hits the equator. And that's exactly what happens in actual outer space. The direct light lands on the equator, and the indirect light is at the poles. So, because there's an even mix of direct and indirect light, that's what we say in the previous picture, that there's a mix of direct and indirect light. Because the northern hemisphere and the southern hemisphere aren't receiving more light than the other in terms of angle, and it's not tilted to the sun or away from the sun, we say it's 12 hours of daytime, 12 hours of nighttime. So you see that? If the axis is not in line with the sun, if it's just parallel to it, then you're going to have one of the equinoxes. And the vernal equinox is just the same way. It's just now it's just going from winter to spring, winter to summer. That helps? Okay, good. So we're kind of near the end. If you got any final questions on part 2 and part 3, let me know. Email, remind. 2 of them are pretty much just written based. The other 3 require a diagram. All right, you don't really have to explain it, but you have to know how to do the diagram, because doing the diagram helps you explain. All right, but just to kind of re-summarize, recap, all the way back to the top of classroom. We reviewed model eclipses. If you want to fix it, you can fix it. Same goes for roll tide. You still have time. All right. The major focus for this week is the study guide. We did part 1 yesterday, reviewed it quickly. We'll review it again Monday, more in depth. You're going to complete part 2 and 3 today, if you haven't already done so. We just did 7 together. A lot of the questions, 5 through 9, require a diagram. The diagrams, I put the dates here. Number 6, go back to March 5th. And then in part 3, go back to March 10th. Those diagrams for the lunar phases are there, and the diagram for the seasons is there. 7 requires a little bit of writing, but I did that writing with you. Focus on the blue and the pink, the blue and the purple. The diagrams are there just to help you visualize. But no, summer is more direct, more than 12 hours of daytime. Winter is mostly indirect and is less than 12 hours. The equinoxes, vernal and autumnal, exactly 12 and 12. A mix of direct and indirect light. Okay? Just being able to write that is good. And then 5, how does the tilt involve the seasons? Right? So how does 5 cause 7? That's really what we want to know. Why did I have to draw the axis in to understand what I wrote in blue, what I wrote in purple? All right. Tomorrow we will do, I'll have you work on the rest of it. I'll work on a couple of them with you. I think I'm planning on working on 12 and 12 and maybe 11 or 12 and 10. I don't know which one I want to do with you. I'll think about it because we already drew a diagram. See if you can maybe draw it on your own. I will do 2 of them with you. We have another 1, 2, 3, 4, 5 to do. And then you'll have your study guide mostly done by the end of tomorrow. That'll be Thursday. Friday, you guys do not have a quote-unquote school day. You guys are off. There's nothing new. You're finishing up what you worked on this week. Get that done. All right, and then we see each other again on Monday. All right, so Friday is a non-instructional day. You guys have the day off if everything you did during the week is done. All right, and then you have Thursday and Friday off next week as well. These come from Governor Raimondo, which is nice of her to give you guys a little bit of a break to catch up. Also gives teachers time to plan out how distance learning should go in the future and anything we have to fix. All right. Any final questions? I don't think I got anything through Remind. Nope. All right. Well, if you do have a question, you know where to ask. Obviously, you can refer back to the stream too. We post that as a comment and through Remind for you guys to take a look at later. All right. See you guys tomorrow. Bye, Rainy. Bye, Azra. Bye, Ryan. Bye, Kaylee. Hi, Eric.